Hello, this is Pablo Valerio with the Times, and I'm here with Teresa Cervero of the Barcelona Supercomputing Center and Stefan Wallentowitz of H&M Munich, the University of Munich. And we're here at HiPEAC 2026, and we had very, very interesting discussions during this show. This is the third day of the exhibition and the conference. And one of the topics that I basically see very often right now is, apart from the fact that there is AI everywhere and everybody talks about optimization of AI, the new designs of processors and architectures and algorithms, and now there is a big topic about using artificial intelligence to design hardware and to design processors. Mm-hmm. So one of the talks this morning has been about LLMs for hardware design. So what can you tell us about it? And especially, in your expertise for example, in the BSC, in the Barcelona Supercomputing Center, and in the university, how are you approaching these new tools in order to design hardware?
Mm-hmm. You first?
I can start. So, sure. For me, the use of LLMs and other machine learning methods really is about increasing productivity, right? It's not replacing, it's really about being more productive, do more new things that you have not been able to do before because you have limited workforce. We have PhD students that want to work on new methodologies, not on coding, right? So we want to be productive at coding, and there's a lot of work now, like LLMs are probably not the best choice, but it's very good experiments that we see already in terms of like writing verification code, helping you designing. It's more like an assistant, right? It's not really like the new PhD student. Like I want the PhD student to use it, be productive, and it's really productivity gains that they can also transfer into industry later. I think this is very important from a university point of view, but you could probably talk more about also as a research center, like more on the backgrounds.
So for us, it's almost the same. So it's not about replacing the engineering work. It's just having an extra tool that helps people to do their work in an easier way or in a more productive way. So the idea nowadays is to use the powerful or exploring the powerful of LLMs for doing other activities. For example, generating system verilog assertions for formal verification, or trying also to help to writing RTL code or some pieces of the RTL code with supervision. So it's not like you leave the system producing the code and then just everything works and we don't need the engineers. It's just as an assistant. But there is a lot of work to do because in this area there is not a lot of research yet. So first of all, we need, as a research institution, we want to work with open LLMs. And we need to train those and understanding how they behave, and then later on to trying to, making them more, usable, let's say.
All right. One of the things that, during your talk this morning that I noticed is basically you're talking about, for example, using open source tools and things like that, because when you're talking about EDA tools are very expensive and not many people can afford them for that. Do you think the use of right now AI and LLMs with open source tools is actually a very good solution for people that cannot, afford the expense of using more commercial, let's say, applications?
I mean, also the commercial EDA tools are using nowadays AI as part of their processes. But I think nowadays what we can do with this is to get the tools closer to the community for students, as Stefan said before. So it's another way to reduce the entry barrier for students. So we increase the abstraction level so they feel more comfortable by coding and this kind of things. And also for SMEs, again, it's a way also to test their designs, doing pilots first and then trying to tune and moving them to a production with commercial licenses or something what they want.
So what about, for example, when we're looking at the trade-offs? Because in a way, using AI for many different things, and not just, of course, we're not just talking about hardware design, but you have the possibility that AI does certain things that you don't want. So when you're looking about the amount of work, using those tools, and basically in comparison to the kind of traditional way, if we can call it like that, what do you think the trade-off is actually very good? Like, getting into using AI as well as basically as a helper,
Yeah, I think that's the aspect, right? You're not, like the people that use it, they need to still understand what it's doing, right? Like the result, you need to understand what it coded for you. And especially in hardware, that's very important, right? Because you can't just fix it, right? Like once it's in the chip, it's done. So obviously you can't just say like, okay, here's my LLM, give it like your statement, your prompt, and then it will design the entire chip for you. That's like you have to do something with it, you have to guide it, you have to work with it. But there was a lot of great experiences already from people like using open source tools and using AI to get new people interested in it, right? Like just say, okay, you don't have to understand the language initially, but you will see how it codes, and then you can, like learning Verilog is much easier if somebody else writes it when you look at them writing, right? I think that's a very good way of creating more influx of people that were not that deep into the topic before. And their AI is like not only assisting them, but also assisting us in creating curiosity.
Okay, just final question. Okay, how do you see the future of this going forward in maybe a couple of years or something like that? And especially because both of you are involved into the RISC-V community and doing a lot of work, in RISC-V design and implementation. Do you think it's actually because of RISC-V being an open architecture, the use of LLMs and open software is actually very important for you right now, coming forward just to really realize the power of the ISA?
Yeah, I think this is really quite interesting, right? Because historically, like, it's very strongly dominated by people that have a long history in this field already, right? And getting in there now and having more people designing processors is great. And I think there's some bright future once there's more training data also and the models get better. It's probably not the LLMs that we use today. It's probably some new machine learning that's trained on this mode, and it's more like an architectural assistant. Like the coding part is the boring part. Like the interesting one is designing the architecture, right? And I think once you have models that understand what an architecture is and how architecture works, this will be very interesting.
What about you?
I think this is a great opportunity for also, again, strengthening the workforce, the specialized workforce in Europe, which we are lacking sometimes. So this is a way and a mechanism that can help us a lot at the university, research centers to gain interest from the community, and also for the companies, because they will have training people and they will have the opportunity also to reduce costs, and hopefully that will help also Europe, to write a little bit more and gaining some, traction and improving the not to say the quality, because we have a high quality companies, but it's strengthening the capabilities.
Okay. Well, thank you very much.
Thank you.
Thank you.
Hope you enjoyed the show and the conference, and looking forward to see you probably in the RISC-V summit this year.
Yes.
Hopefully,
Okay?
yes.
All right.
Thank you.